Welcome back. My name is Eitan Suez, Technical Marketing Manager at Solo.io. And in this lesson, we get hands-on and we install an implementation of the Gateway API, the open source kgateway project. In the previous lesson, I gave a high-level overview of the Gateway API and the motivation for its creation. And from this lesson on, we get hands-on. So we're not going to spend much time doing presentations. We are going to enter an environment with a Kubernetes cluster where we can actually play with the Gateway API. And the first task that we must go through before we can do that is to actually apply the CRDs, the custom resource definitions for the Gateway API, and then provide some backing implementation. And we'll be using, of course, kgateway, a conformant implementation of the Gateway API, an open source project donated to the CNCF. We'll also be reviewing the Gateway class resource. And if you recall from the previous conversation, the Gateway class resource is really the concern of the infrastructure providers. Okay, let's get going. Let's step into our environment. And here we are presented with a terminal with access to a Kubernetes cluster. We should be able to verify that we have this is a simple sandbox environment with, I think, a K3D instance running. We begin by applying the Kubernetes, the custom resource definitions for the Gateway API. So here's a command that I'm going to run that will essentially apply the experimental channel. There are two channels that the API discusses. If you work through the getting started guide in the documentation, there is a short description or a brief summary of each, the standard channel and the experimental channel, and so you can consult that for more information about that. Once we've applied those resource definitions, we can run a simple kubectl API resources command to look at the new CRDs that were added to our cluster. And so here we see our Gateway class, Gateway, and different route resources, in addition to some of the experimental resources, TCP routes, TLS routes, and so on. So great, so the CRDs are there, but we need a backing implementation, and so this is where kgateway comes in, and we're going to use Helm to install some of the early builds of kgateway. Maybe I should take a moment to mention that if we go to the kgateway project on GitHub, we see that at the time of recording we have nightly builds of kgateway on the way. Again, this was the venerable Glue open source project, now rebranded and part of the CNCF. And so we do a Helm install of, and the sort of typical namespace that we use is the kgateway system namespace. We follow sort of a convention there, and we can look at our namespaces and see that it's there. If we look at the pods in that kgateway system namespace, we see our controller. This is the kgateway controller, the control plane that is going to be responsible for provisioning and programming gateways for us. Now, the interesting thing to point out at this juncture is there are no gateways in sight yet. We haven't yet provisioned a gateway, and that will be actually the subject of the next lesson. So this lesson is rather short. Now, before I leave you be, we should talk about the Gateway class resource. So don't forget to consult the description of the Gateway class. The one sentence here that really stands out describes the Gateway class allows the decoupling of which mechanism or which controller implements gateways from the user. And so what we mean by that is when we define gateways, when the cluster operators define a gateway, they're going to be referencing a gateway class which will sort of bind their gateway to which implementation or which gateway configuration they want to use. So if we look at the Gateway class, what's interesting is that one was created as part of the installation. There is a default Gateway class for kgateway, and we can create our own as well if we're infrastructure providers that want to sort of expose other configurations or base configurations for an Envoy gateway. And we can also look at the YAML specification for the Gateway class, and we can see here the controller name, kgateway, is being referenced there. There's also a mechanism to configure, further configure the particular infrastructure, in which case here we see kgateway has a custom resource called gateway parameters, which provides ways of further configuring that Envoy. And there's also a status section that shows that the control plane has been accepted and that it's a supported version, so it's up and running and we're ready to proceed. So this was a quick and easy lab. We sort of deployed kgateway and applied the custom resource definitions. Let's go back real quick and wrap up our conversation. The main lessons here is that, again, the CRDs must be applied explicitly, that we need an implementation, a conformant implementation, and the gateway class resource is one that allows you to then proceed with the definition of gateways that bind to a particular implementation. In the next lesson, we are going to do the next obvious thing, which is to start with the most common scenario, which is to provision a gateway and define a route and send traffic to a backing workload. So we'll see you then, and thank you for your time.